Hello, class. How y'all doing?
Good.
All right, everybody sign the roll.
Yes, sir.
All right, all right, all right. Okay. Anybody with any issues with the y'all had to do the bonus assignments, or y'all still got time to do them though, right? Anybody got issues doing the two programs that I had you to do in either in Dual or Expo or what it is, the other one, online GDB. Anybody with any issues on that? None. Anybody with any issues with the quiz conversions, the binary, the decimal to binary? So everybody somewhat understood that. Okay, we're gonna do the octal and hex today also. We're gonna complete the chapter, and I'm well I think at 11:30 your test will become published so you can take it. You're gonna have the acknowledgement of you reading the chapter or reviewing the chapter. You're gonna have a quiz for chapter 1, and then you're gonna have the test that will be available throughout the week from today until Monday. The test will be from today to Monday. The quizzes will be from today until I think Sunday, if I'm not mistaken. All right. I think I might have another quiz. So let me share my screen and let's look at this. All right. So I share my screen and let's go back here. And we'll go to modules. All right. Yeah, so I did post, well, it will be posted the other quiz, the octal hexadecimal conversion. But we'll go over that today. All right. And like I say, your test has been published also. All right, you have that test 1. Any questions before we get started with the notes? We'll do the notes. I think we got a few pages left with the notes, and then we'll go to the conversion. All right, any questions? All right, so let's go back to our notes. In our notes, we looked at how character data is somehow stored into the computer, and we said that the character data was actually stored in as numbers. And what we talked about a byte is a single character. All right. We took example like BRCC. That's 4 letters. Those 4 letters, each one represents a byte. So BRCC in itself is 4 bytes. Now, we also said that 1 byte is equal to 8 bits. So BRCC would be divided up into 8 small pieces, where the B would have 8 bytes representing 8 bits representing its value, or the next 8 bits represent its value, the next R 8 bits representing its value, and the C. Well, wait a minute. BR, then the C and the C. All right, and the last C represents 8 bits representing its value. So that's how the data is actually stored in the computer. All right. So, but you as a computer, it tells you that there's many different data types. All right, computers are often referred to as digital devices. All right, the term digital can be used to describe anything that uses binary numbers. Because, like I say, no matter what image you take, it is converted what to binary so that the computer can understand it. And the video taken, it eventually is converted to binary so the computer can understand it. Music is converted to binary so the computer can understand it. So, like I said, you have all types of data, but that data is eventually converted so that the computer can understand what it is. All right. Uh, and then I think we may have gotten into this, if not, how a program actually works. What happens is a program has to be loaded into your computer, into main memory, into the RAM memory. Then it's executed through the CPU, the lines of instructions. And then what? It produces the output. So basically, that's the process of how information is actually processed within a computer. Right. And there's many other things going on in that, but that's the general concept. It says a computer CPU can only understand instructions that are written in machine language. Now, machine language, that would be language at a low level. Machine language is low level language. We write code in high level languages. When computers was first developed, you only could write in low level languages. All right. But we now write in high level languages. And one benefit to that is nowadays we don't have to worry about where the computer is storing the information. Like if I create a variable, we're going to get into that later on. A variable would be just any identifier, whether it's a computer, something a variable within the computer, or a user-defined variable that can hold a value. All right. So uh, when you create a variable and assign it a value, matter of fact, when you create it, the system has to allocate space for it so it'll know where to find it. Um, in low level programming, you will have to know that address or either pick the address and say, this is where it is. High level language, all you need to say is, I want to use this variable. And what happens is the system says, okay, I'll allocate that space for you. You don't need to know where it is. You don't need to know the address of it, which you can still find the address, but you don't have to worry about that. All you have to worry about is making your program work. So that's some of the benefits of writing code in a higher level language. All right. So it gives these things as to what can be done in the process of computer program. So it says that the CPU is designed to perform operations such as reading a piece of data from main memory, so it has to be loaded in RAM, and then it's read into through the CPU. You can do calculations on numbers, add, subtract, multiply, divide. You can move data from one memory location to another. And all that's saying is if I have a variable X, a variable Y, they both have two different addresses. I could copy the information that's stored in X and into the variable of a Y. All right. So, things of that nature. Determine whether variables are equal. So now we can do comparisons. Whether something is less than, greater than, equal to, not equal to. So all these things can be done in the CPU. And we'll be doing that with our code. All right. So that's basically what it's saying. All right. Now, and it goes on further to talk about the CPU and its purposes. All right. uh, Programs are usually stored on secondary storage devices. And what all that's saying is when you write code, you normally save it So you either can come back at a later date and execute it, or either continue to modify it. But the program is actually, when you run it, it's stored in the RAM so that it can be run, all right, through to be executed. And so here it just gives you an example. If I have a file on this hard drive, I've created a file. Say I've created it in Visual Studio. I want to execute that file. Say I run the program, I got all the errors on it. In order for me to run that file, it has to be read from the disk, stored into main memory, and then executed through the CPU so that you can get your results. So what happens is you have your file, all right, that you've written. It's coded, then decoded into machine level language so that it can be read into RAM and then actually executed on that computer. So those are the steps that it takes. So it's say first information is fetched, then it's decoded, and then it's executed. So that's the process that goes on. Now, it talks about machine language. All right, from machine language to assembler language. Assembler language is a low level language. All right, it's many people do not even write in assembler language because it's a very low level language. You have to, you can pretty much mess things up writing code in low level languages because what? I can overwrite a memory location that I didn't intend to. I can access certain areas on the computer writing in low level languages. C++ can be used as a low level language, if you become an expert at writing code in C++. And if what I said, many viruses are written using these low level languages because what? A user can access certain restricted areas or whatever, or memory locations or manipulate data at a low level, which causes your system not to run in this proper manner. All right. So, but it says computers can only execute programs that are written in machine language. All right. As previously mentioned, a program can have thousands or even millions or more binary instructions, and writing such a program would be very tedious and time consuming. All right. Programming is machine language. Programming in machine language would also be very difficult because putting zeros and one in the wrong place can cause an error. And what that means is it's easy to read something as to say, see out or output, my name is, and whatever your name is, rather than reading 0010110110001000, trying to understand what that means. The computer understands it, but we as humans, when we looking at nothing but zeros and ones, our eyes may play tricks on us, or we might skip a zero, we might add a one, and therefore throw our whole logic output off. So, like I say, it would be very difficult to write programs in just zeros and ones. All right, but being like I say, as computers evolved, programmers started writing or developing more upper level or higher level languages. All right. All right. So looking at this now, this would be some code that is written in assembler language. This is a low level language, and it's saying move, and this is a command move, and it giving you this information, and it says Z. They give you this information. So this is executed. All right. It's passed through the compiler or the assembler, and then look what happens. This is what the machine actually sees. All right. So to just look at this, you would not really understand, or it would be hard to comprehend what this actually means. The computer knew, but with us, we could interpret it as many different things. Just giving numbers. How many people have just saw a string of numbers? Depending on the length of those numbers, we interpret them as in different ways. When we see a number that's number dash number dash number, we say, oh, the most logical thing that could be is a social security number. All right. When we see a number that has say number dash number. So that's 5 numbers dash 4 numbers. Logically, we would say, okay, that could be a zip code with its extra digits. You understand? So but like I say, we just guessing. We don't actually know that because it could be just somebody used that pattern to do something else. So it would be hard for us as humans if we dealt just in numbers, because our mind can't, process information fast enough, number one. And then as humans, we interpret a lot that's not there, which can cause problems, right? So high level languages, we said high level language gives the user or the programmer, the flexibility of not having to worry about a lot of the things that go on within the computer. All right. So it says, although a similar language makes it unnecessary to write binary machine language instructions, it is not without difficulties. That machine, that's assembler. Assembler is hard. It's a low level language. Assembler language is primarily a direct substitution for machine language. So it's so close and it's pretty much performing the same way. It makes it very difficult. All right. All right. And like machine language, okay, it requires you to know a lot about the CPU, what addresses are available, where I'm going to put this, where's address, many different things. A similar language also requires that you write a large number of instructions for even the simplest program. So if you're just writing a program to add 2 numbers, it might take you maybe a few more lines more to do than it does with a higher level language. All right. So it tells us back in the 1950s, a new generation of programming languages known as high-level languages began to appear. So what happens is all of a sudden now that code that took maybe 30 lines of code to write, all of a sudden now you can write it in 3 lines, 4 lines, and you're done, which made it much easier to understand and much more, how would I say, easier to teach, so more people got into computer science and started being coders and whatnot. But back in the day when it was just machine level language, you were learning based on that machine and pretty much that's it. All right. So on the following page, it shows some different languages. But in this example here, it tells us about COBOL. And you got many different programming languages. If I had to give you a comparison of COBOL and Fortran, you might not know the 2 different languages, but Fortran was pretty much a scientific programming language. All right, more of your researchers and whatever scientists used Fortran. All right, Fortran, you could write your statements. You can write in your expressions. Boom, you got your answer. COBOL were more or less a business-oriented programming language where you wrote code to generate reports like inventory reports, stock reports, whatever. So in that fashion, if you had to write the same program you wrote in Fortran to maybe just write to calculate something based on an expression, in Fortran, those 5 lines all of a sudden may have become maybe 15 to 30 different lines. Why? In COBOL, you have different sections that you have to have in your program. Yeah, some of the sections you had a date. Well, you had a data division. You had a input output section. You had a working storage section. You had a procedure division. So all these different divisions, you had to have certain code written in it. All right. So once you did all that, that's just code just to set up the program, and you haven't even written the code to either input the data, to describe what the data is that you're using, and even to output the data. So it's two different programs. You can get the same results, but one would require more statements to perform. So what happens is over time, and like I say, these are just a few that the author mentioned, are programs that were developed. You got Ada. To me, Ada was kind of close to C++. Kind of similar. You had Basic. Back in the day, Basic was a language that came with Windows. But over time, they had the Visual Basic, so now it's a language that you pretty much have to buy, and it comes with the Visual Studio and all that. But now it's a little more cumbersome and powerful because it works with Windows in a Windows environment. Fortran, which was the language I was telling you about just now, it more or less was a scientific language. COBOL, business type language. Pascal, similar to it was. If you wrote in Pascal, you could kind of convert over to C++ somewhat seamlessly, but it was still a little different. Give me an example. And we're gonna go over in C++. I could say int x semicolon. I think with Pascal, you had to say something like X colon. Rather than the semicolon, the colon was the end of the mark, end of the statement, if I'm not mistaken. So you got different languages do the same thing, but it's written, in a different way. Then you have your C and your C++. Even though it says C, C++, you got C sharp. The next one. They're all in the same family, but they do have different functionality, or how would I say, different ways about writing them. Like with C, I think you got printf, whereas C++ you got C out, so different things like that. So even though you're in the same family, you still have different ways of writing that code. Then you have your JavaScript. Once they came out with the Windows and whatever, now they came out with your JavaScript, which deals with your web pages, and now you can have different things, different little frames on your screen that may have a animated activity. JavaScript also allowed you to validate your text, because in my code that I wrote with PHP, which that's a web-based programming language, I use JavaScript. So if I had you to input alpha data that was alpha data, I could write the JavaScript that says, okay, only accept alpha data. If not, shoot them this error message. Right. So that's what the JavaScript does. Python. A lot of people use Python to write research. Some use it for the gaming side of programming. Also, and like I say, and they use it also in the educational field too. Ruby, I never used Ruby. That's another language. And then again, the Visual Basic. But these are just some of the different programming languages that are out there, the higher upper level programming languages that have been created. All right. So it tells us, high level languages, we can write out statements that we can understand as humans. 12 plus 75. We can just write that out rather than having to write code to take a number, convert the number, add the number, then convert it back to whatever, store it, and then, do whatever we need to do with it. So it just made it much, much easier to write code. Now, compilers and interpreters. I think we close to the end of the chapter, or we should be. Let me see. Yeah, we close to the end so we can get to our conversions. Where was I here? All right. So compilers and interpreters. What's a compiler? What's an interpreter? They both do the exact same thing. They take code and they process it to see if there's errors and generate object code, which in turn and then create an executable file. They both do the exact same thing, but the way they go about doing it is different. A compiler will, if I write code, say if I have 20 lines of code, a compiler will check each and every line of code. Even if it finds an error, all right, it's going to continue checking my code. So what happens? Depending on what type error I have, I might have 15 different errors, or it might show 50 different errors because something I did in my program was wrong. All right, but it didn't stop the process of trying to compile the program. All right, that's a compiler. But once I get all the errors out, then I can create. It creates a file where it's going to give me whatever output that that the program generates. On the other hand, what an interpreter does, it says, okay, I read this first line, it checks. I read this second line, it checks. I read this third line, oh, I found the error. Kill it. It kicks you out and says, oh, you have an error on line 3, such and such and such. So now you fix that error, you compile it again, or you run it through to generate your code again. It's going to read the first line, check. Read the second line, check. Read the third line. If you fix the error, check. Read the next line. If it finds an error, oh, it stops, tell you that you have an error. You fix the error, then you go back in and run it and whatnot. So you run that process over and over. So the compiler gives you all the suspected errors. An interpreter gonna run and stop and say, oh, I ran up to this point and now you have an error. Which one is the best? There's no right or wrong answer. Some programmers choose compilers. They like to code in compilers. Some programmers choose interpreters. They love to program using interpreters. So, like I say, both gonna give you the same results. It's just the way in which you go about getting the results. All right. So that's the difference between an interpreter and a compiler. All right. And it's just showing you what happens. You write code. The compiler takes it and converts all that code, if it's no errors, into machine language so that it can be executed. Okay. All right. And simple as that. That's all that happens. All right. Interpreter, same thing. It takes the code, interprets it, turns it into machine language so that it can be executed. So they both do the exact same thing, but it's just that one will stop at the very first error, and the other one will continue and give you all the errors they think you may have. All right. The book talks about here integrated development environment. All that's saying is an integrated development environment is an environment where you have a package, like say a Visual Studio, where you have the editor, the compiler, and everything all built in that one application. All right. Because what? If I didn't give you Visual Studio and told you, well, we're going to use, let me see my a compiler. Well, there was just an independent compiler, all right, that you had to load on your computer. You may have had to go into a notepad, type up your code in an ASCII file or a text file, save it, then go to the compiler, upload it into the or execute it into the compiler to see if it works. Compile it to see if you got all the errors out, and if you did, then it works. So what they did, they created integrated environments where a user don't have to get out and go to another application to write the code, get into the application, check the code, and run it, and then get out of that and then run it. Everything is built all together. All right. So that's all an integrated package is. All right. So, and then it tells you the different, if you load the entire package, these are pretty much most of the applications you can have in the Visual Studio, C Sharp, Eclipse, which Eclipse they use for Java, NetBeam, Dev C++, so you can have all these different ones uh, uh, within that environment. So you don't have to go out and get another application, do it, and use another editor, whatever. All right. The types of software, I think we already talked about it. You got system software, which would be more or less your operating system, right? Every device has some type of operating system on it, all right? Some software that's gonna run or manage the processes that's on that system. Okay, I need to display. Okay, that operating system gonna control that. Oh, I need to print. The operating system gonna have something in there which allows you to control what's going on, whatever. Executing programs. The operating system gonna give limits or whatever as to what and how you can do on that device. So the operating system. An operating system is the most fundamental set of programs on a computer. The operating system controls the internal operations of the computer's hardware. All right. And then it manages all other devices, device connections, and all that. So that operating system is there. Now, I don't know how many people have dealt with Linux, but what happens is Linux is and most of the Linux applications have been is open source application. So you can take a Linux shell, and depending on how experienced you are in programming, you can take that shell and fine tune it to how you want that operating system to work. Give an example. You might want it to be more resource management heavy, or you might want it to be file resource heavy. You can go in, they go in and they do things to the operating system to say, hey, I'm concerned about resources. So I want to modify it so that it'll keep my resources managed and whatever. And so that because I'm doing more with my resources than I'm doing with my actual system and certain files. So, because it's open source, so you can change it up as needed. There's utility programs. Your utility programs is just programs that how would I say, assist the operating system. All right. In that what? Okay, your operating system is on your device, but yet what? From and deleting and whatever, creating folders, doing whatever. Sometimes you may have junk files. A utility program could be something that says, okay, go in that system and look for all type of junk files, look for all type of log files, look for all type of temporary files, and just go and remove them to free up space on your computer or to do whatever. Back up my system, fragment my hard drive or whatnot, so it'll run faster. So stuff like that, that's utility programs. But then you have software development tools or software applications like, your Word, your Excel, your PowerPoint, your internet browsers. Those would be application software that you as a user decided to use, and install for your specific needs. All right. So here they listed, a few operating systems. We know Windows is one. The iOS, okay, that's another one. You have your Mac OS systems, and we have and they mentioned the Linux system. All right. So these are just various operating systems that's out there. right? And then software applications, like I told you, that would be applications that you might buy independently or download independently to use on your computer, for your specific needs. All right. So this is the end of the chapter. The test will be available. Oh, class. No, class not ended yet. Class started at 10. All right. This to go through your review questions and whatnot. So your tests will be out there and your quizzes. So now let's look. Anybody with any questions so far? Any questions? Okay. No question. Let's look at our conversion.
I have one question.
Yeah.
Where did we get the answers for these? The review things.
They're in the chapter.
So they're not macros. Just here's A, here's B, here's C, D, F.
No. Are you talking about like this?
Yeah, like they would be like A.
No, you got to look in the chapter. Yeah.
Okay.
Yeah.
Also, one more thing.
Look at the first one. Now, like I say, we want A or and blank is a set of instructions that the computer follows to perform a task. What we talked about was a set of instructions.
The interpreter or process?
No. Remember, a compiler and an interpreter, they allow you to what? Write the code, write program statements so that they can be what? Executed or compiled to see if there's errors, and then eventually they turn into machine language. A compiler or an interpreter. It would be B. A programming language, that would be what? COBOL, Fortran, Ada, C++, remember? So remember we said a program, step-by-step instructions that perform a particular task, right? So, and that was toward the beginning of the chapter, right?
I still have another question. Are you going to open the quiz we did last week so we can see the answers? Because it won't let me.
To what?
The quiz the binational quiz. I got it all right. I only did it once. Because I only did it once, it won't let me do it. It won't let me look at it.
Right, yeah. It's set to where you after the second time you can see the answer. Yeah.
Yeah, but I really only did it. I got 50 out of 50, so I didn't think I need to take again.
Right, but if I said I have to set it for how would I say it? No, that's how I said it, because like I say, once you go into the second time, you'll be able to see it. Because if I change it, then it'll change for everybody, and then people do it one time, get answers, and try to copy the answer for the second time. So, you know what I'm saying? Yeah. Okay. Right.
But now I can't do it because I didn't.
Right, but you made 100, huh?
Yeah, but I still want to see them so I can study for them for the test.
Right, but what you can do, the binary won't be on the test. But say you wanted to study your binary, right? Write down some decimal numbers and then convert them. You understand what I'm saying?
Oh, okay.
And or write down some binary numbers, then convert them. You got what I'm saying?
Yes.
Yeah, you can do it that way.
Okay, thank you.
All right. Anybody with any other questions? Okay, so let's look at let's go to the SYL site. All right, so we looked at converting binary to decimal and decimal to binary, right? Remember our conversion table. And if you had issues, you could either do a Google on how to do it, or you can actually go to YouTube and they have videos. But also in these notes, they had the instructions here on converting from binary to decimal, or decimal to binary, then binary to decimal. All right. Now let's look at the next one, binary to octal. Right. So, let's see. Did I have binary? Yeah, here we go. Binary to octal. Now here you're gonna have to know the process. What happens here is we want to take a number that's a binary number, a number that consists of only what? Zeros and ones. And we're going to convert that number to an octal number. Octal is base what, class?
8.
Base 8. What are the valid digits in base 8?
1 through 8.
Remember we said the computer always starts at what?
0. 0 through 7 then.
All right, 0 to 7 is 8. Just like 10. Base 10 is what? 10 digits, which is what?
0 to 9.
0 to 9. So you got what I'm saying? So base 8 would be 0 to 7. Now,
Yeah.
so that's base 8. So if you see a number that has 19554 and an 8 at the bottom as to say that's base 8, that number would be what? Invalid. Correct? You could spend all day trying to convert that number to a binary number or whatever. It's an invalid number because 9 is not a valid digit in base 8. Everybody got that? 8 is not even a valid digit in base 8. So look at what they say here. We're given a number 100101010. That's our binary digit. So what it says, how can we convert this binary digit into an octal, its octal value? It says, first you need to take the binary number and divide it in bits of 3, starting from the right, going to the left. Now, who could tell me why you would start from the right, going to the left? Anybody?
Because you got to convert it.
Okay, yep. And
if you start from left to right, you might not get sets of 3.
Correct. Because what? With numbers, you could always add zeros at the beginning. That's just insignificant digits, right?
Right.
But if I add numbers at the end, I'm increasing my value of a digit, right?
Right.
Because if I say I had the number 100 and I had a 0 at the end of 100, that changes 100 to what?
To 1,000.
To 1,000.
0, 100.
That's right. But if I have the number 100 and add a 0 at the beginning, it still can be interpreted as what? 100, correct? All right. So that's what the reason why we go from right to left. So given this number here, it says start from the right, going to the left, section off the number in bits of 3, all right? In every 3 digit, all right? Once you do that, they telling you to create or use your binary table, all right? From 2 to the 0, 2 to the 1, 2 squared, because you got 3 digits, and find out its binary value. So let's look at this number. We got 100. So it took 100 and placed it under this table. 100, the value is equal to what? 4, right? So what? You got 4 times 1, that's 4, plus 2 times 0 is 0, plus 1 times 0 is 0. So 4 plus 0 is 4. Now, you take the 101, you place it under the placement table. That's 4 plus 1, that gives you what? 5. Then you take the next set, 010, that's what? 2. So now I take these numbers, 4, 5, 2, and look, 100, 101, 010 in base 2 is equal to 452 in base 8. Everybody got that? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So that's how we convert. And like I said, you got to know what you're converting from to, right? So we converting from binary to octal, right? So anytime you have that and you're converting a binary number to octal, divide that binary number up in sets of 3s. Now, let me ask you this question. Who could tell me one reason why they would set up, that section it off the number in threes? Is anybody? Let me ask you this. What's the highest value that can be the highest digit in base 8?
7.
7. Look
So
at this
4,
plate.
2, and 1 are added to 7.
Say that again.
4, 2, and 1 are equal to 7.
Right. So that's the highest value you can get. If once you break it up in 3, that's the highest value you can get, right? So everybody understand that. So that's why you break it up in 3s. Then you, like I say, place it under here. The number can either be from 0 to 7. That's the only valid number, right? Everybody got that?
Yes, sir.
All right. So just remember that when you're working with it. Now, if we, in converting a binary number to octal, had to divide the number by 3 to get, and then get our answer, to convert from octal to binary, we simply do what? We take the digits, all right? So like this number, 603. Take the 6 and write out its binary value under here. Take the 0, write out its binary value here. Take the 3, write out its binary value here. And then what? 110000011 is equivalent in base 2 is equivalent to 603 in base 8. Everybody see that? Questions? Everybody saw what happened? Any questions? Hello?
Oh, sir.
All right. So you saw what happened. We took each digit that was in base 8, 603. And like I say, this digit, it could be longer than that. It could have been 60385. No, not H, Christ that. 60374513114 in base 8. We just have to take each individual digit and what? Represent it in the 3 binary digits. Right? Everybody got that? Now, sometimes what? If this was a 3 at the beginning, that would have been 010. You just throw away the 0 at the beginning, right? Because it's insignificant, right? So those are some of the things you need to pay attention to. So that's converted from octal, well, binary to octal the first time, and then octal to binary here. Now, there could be other ways that you can do it. You can look on YouTube. It might be another way that you might understand it a little easier, but this is the instructions that, that I have posted, and, you can follow these and it shouldn't be hard. All right. So now let's look at how to convert an octal number to base 10. All right. Now, when we're dealing with going from octal to base 10, we have to use our octal placement table. Remember our binary placement table? 2 to the 0, 2 to the 1, 2 squared. Look at our octal table. 8 to the 0, 8 to the 1, 8 squared, 8 cubed, 8 to the 4th. You understand? So any base, if we wanted to do the base 10 table, 10 to the 0, 10 to the 1, 10 squared, 10 cubed. You understand? So you can write out any placement table that you want, starting with what? The number to the base to the 0 power and incrementing it. All right? So now, they took this same digit, 603 in base 8, and they're trying to convert it to base 10. So what they did was, starting from the right, all right, to the left, you plug in these numbers, all right? All right, it's 306. So you put the 306. Start from the right. Because again, you don't want to start from the left and have one number extra. You got to start back over again. Because the number don't have to be that small. It could be large numbers. So if you learn that process, using small numbers, when you get larger numbers, you'll be okay. So Start from the right, placing that number under the eighths placement table. Now, all you do here, 64 times 6 plus 8 times 0 plus 1 times 3. All right? So it shows us 64 times 6 plus 8 times 0 plus 1 times 3, which is equal to the 384, that's the 64 times 6, plus 0, that's the 8 times 0, plus 3, that's the 1 times 3, giving you 387 in base 10. So 603 in base 8 is equal to 387 in base 10. All right? Everybody understand? So we took a number. So let me ask you this. I'm going to ask you this question. 110 in base, well, no, I won't say one. I'll say 101 in base 8 is equal to what in base 10? Anybody? 101 in base 8 is equal to what in base 10?
The 65?
What is it?
The 65?
65? Yes. Because what? 101.
64.
64 times 1 plus the 1 times 1, and that's 64 plus 1, that's 65. Right? Everybody see that? All right. So that's how you would do it, to get from an octal to a decimal, octal to decimal. Now let me ask you this. 101 in base 8. Well, I'm looking at this table. Let's just say 101 in base 8 is equal to what in binary? Not decimal, but binary. So you have to move up to that other previously used process, right? So what 101 in base 8 is equal to what?
1000001, right? Be 5 zeros. Okay.
It would be, so you put the you put the 1 right here. That would be what? 001, right?
Yes, sir.
Correct. Then 000. Then 001, which would be what? 1, like you said, with what? 5 zeros and a 1 in the base 2. Did everybody get that? You took the 1. How would I represent 1? 001. 0, how I represent 0? 000. 1, how I represent 1? 001. And put it together, you got 001, 000, in base 2. Right, class? Anybody with a question about that? Hello?
Oh,
All right. Okay. All right. So now we looked at the binary to octal, octal to binary, and octal to decimal. So let's look at hexadecimal. Hexadecimal is base what, class?
16, I think.
Base 16. What are the valid digits in base 16?
0 to 15.
Digits, the valid digits.
0 to 9.
That's base 10.
Wait, what was the question?
What are the valid digits in base in base 16?
0 to 9.
That's
Not 0
base.
to 15?
That's base. Huh?
Base 16.
Yeah. What are the valid digits in base 16? 0 through what?
Oh, 0 to 5.
0 to what?
0 to 9 and A through F.
to 0 to F. What happened in computer science? Well, say take numbers. When we write a number, or we represent the number in putting it in its digits, in its how would I say it, in its perspective column, that number can only be represented by 1 byte or 1 character, correct?
Yes, sir.
That's why you get 0 through 9 for base 10. I can't write 1 0 and put it in a column, in a slot. No, it can only be a single digit. So what happened in computer science, they said, okay, we done ran out of numbers, so we're going to start using what? Letters. So it went 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So when you see a number in computer science, now when you see that, when you see like A 1 5, F C 1 2, whatever, in like say on a paper, you'll say, oh no, that's not a number. But if you're in computer science and you see that, you say, oh, that's a hexadecimal number. That is a number. You know, you're thinking a change. So looking at this, our valid digits are 0 through F. Now, 0 is 0, 1 is 1, 2 is 2, on and on. 9 is 9, A is 10. So when you see A represents the decimal 10. B represents the decimal 11. C represents the decimal 12, and so on. Now, look at its binary representation. Basically the same as before, but what happens after base 8? I mean, the base 8 right here. 7 is the highest value for base 8? 111, right? The 0 is insignificant. But when we get to base 16, 1111 in binary is equal to what in decimal?
15.
How many?
15.
How many?
15.
All right. So it's 15. So just like 111 was the maximum, well, not 111. 3 columns or 3 bit columns was the maximum for base 8. When you're going to start dealing with base 16, what's going to be your max column when you're going to be converting something, from a hex? It's going to be 4. You got me? So now let's look at this. We look at this number, a hex number, 75CE. That's a valid digit, right? C is valid, E is valid. So when you look at this, when you see this 756 CE, base what? 16. If this was base 10, you know that would be invalid. Base 8, invalid. Base 16, oh yes, okay, it's valid. So now, what you need to do, represent each one of these digits by what? 4 bytes on a binary value in 4 bytes. So what? 7 is represented by what? 0, 1, 1, 1. Look, 0, 1, 1, 1. Now, 5 is represented by what? 0, 1, 0, 1, right? 0, 1, 0, 1. So all you're doing, taking it in its 4-bit representation and writing the zeros and ones for each one of these digits of base of the base 16. Then C is what? 12. How's 12 represented? 8 and 4. 1, 1, 0, 0. All right. So look. Well, basically, it don't have it. But if this had 2 to the third power, 2 to the third power is 8, right? So that would have been 8, 4, 2, and 1. So what? 1, 1, 0, 0, 8, and 4, that give you 12, 0, 0. So that's how they got the 1, 1, 0, 0 for C. Then E is what? E is 14. 14 is 8 plus 4 plus 2. All right? And then add the 0 for the 1. All right? So That's how they got 775 CE in base 16 to equal to this number in base 2. Questions? Anybody with questions? Did you go? Yes.
When we're taking the test, will we be allowed to use like a printout of these?
Yeah, you go. Yeah. No, well, listen, I won't test you on this. All right. You won't be tested on this, but you're gonna have that quiz. You understand? And like I say, you could print this. You could print this out if you want, and do your quiz. And it might make it a whole lot easier and simpler. You know, where you won't make a mistake. You know, you can use the charts or whatever to do the quiz.
Okay.
All right. All right. Now, so just like in base 8, if we had to divide, well, not divide, if we had to represent the number in 4 bits, if we have a binary number and we need to convert it to hex, now we need to what? Starting from the right, going to the left, divide the number by what? 4 bits. Everybody understand that? So in this, let's look at this one. In this one, we had what? 603 in base 8. And not here, right here. All right, so we had the number, we had 100, 101, 010 in base 2, and we was converting it to base 8. If we had the same number here, and we wanted to that binary number, and we wanted to convert it to hex, what would we have to do to that number?
You would have separated into 4s.
Correct. Starting from the right, going to the left, separated by 4. So see why you got to know which option you're using or what conversion you're doing to know what the rule is, right? So if you're going from binary to octal, you divide by 3 or separate the numbers in 3s. If you're going from hex to binary to hex, then you separate the numbers by 4. So look what they did. They took this number here and they separated it by 4. Now what happened here? You had a 1 here, and what? It could look confusing. Well, they don't have it's not 4 represented by 4 bits. Just add 000 at the beginning, 000 at the beginning, and you got your 4 digits. So what? 001, well, 0001 is what? Still what? 1. 0010, all right, and look at the chart here, 0010, that's 2. But what they did do? All they did was what? 2 to the 0, 2 to the 1, 2 squared, 2 cubed, all right? And then put the number under that placement table and got your answers. All right, so that's 2. Then you got 1010. So that's 8 plus 2 to give you what? 10. 10 is what? The letter A. So that's this number here in base 2 is equal to 12A in base 16. Any questions? Questions? Anybody?
No, sir.
All right.
No,
So, all right. So what happens is, let's go. Let's say we don't went over the conversion. Like I said, you could go over this. You can look at YouTube and look at some other conversions. You could Google it, because it might be some other way that you can understand a little bit better. I don't have issues with it, but like I said, I need you to take my quizzes. So look here. Let me open up the quiz to show you. Wait a minute. Yeah. All right. So look at this quiz. All right. I'll click on this quiz. All right. I'm gonna just open it right quick. All right. So it tells you. Oh, I missed it. All right. Input your answers, omitting leading zeros. Everybody understand what that means? If I went through my process and I got an answer that was 0111, just omit the 0 and just put 1111. All right. Don't put the base whatever. You don't need that. All I need is the actual answer. All right. Because I'm telling you, go from this base to this base. All right. So you don't need to put the base. All you need is the answer in the block. So if I go here to the question, look here. This says to convert this number from base 2. So this is a binary number. Okay. Convert this number from base 2 to base 16. What's going to be the process, class? Starting from the right, going to the left, do what?
In the 4s.
Divide it into 4 and then solve for the binary value. That's right. What that, like say what? 0, 1, 1, 0. That's what? 4 plus 2. That's what? That's 6, right?
6.
So that's what you'll get for that. All right. So that's the process. But look at this one. You got this number here in base 2, all right, which is binary. You want to convert it to base 8. So what's the process here? Starting from the right.
Break it up into 3s.
Break it up into 3. So you understand? So it's different techniques you got to follow for whatever conversion you're doing. All right. So, and then if we look further down, we have this. We have D1F08C. Is that a valid number? A hex number? Are all these digits valid in hex?
Yes.
Yes.
All right. So now it says convert that number to binary. So what you going to do in order to represent this in binary? For each digit, I'm going to represent it in what?
In binary from right
Four
to left.
binary bits, right. And if the first one got 0, 1, 1, 1, then you're going to just omit the leading 0, right?
Yes, sir.
All right. So now look at this last one. DEAL, def. Is that a valid hex number?
Yes, sir.
Yeah,
Yes.
it just spell a word, but it's a number, right? Right. So that's the quiz. That's the quiz. And like I say, take your time. I don't know if I have it timed or not. I think I might have it timed to like maybe an hour or something. 60 minutes, yeah. So you got an hour to do those. So like I say, take your time, get them right, go back, check your answers. You got 2 chances though. Like I say, but go back, make sure you get it right the first time and then you're done with it. Okay? All right. But that's the quiz. All right. Like I say, the test is out there. You're gonna have to make sure you have that extension, Proctorio extension loaded in your web browser before you can take the test. The quizzes and the other thing, you don't have to worry about it. But for the test, you're gonna have to have that Proctorio installed on your computer. All right. And like I say, I think you can do it here. See if I go here, all right. It says it's already installed. But if you try to take it without it, it'll give you a screen, and then it give you that option to download it, and you can go ahead on and download it, and you'll be able to take the quiz. Sometimes you may have to exit out the browser and come back in and log back into Canvas. Sometimes, depending, you may have to reboot your computer. But try that before you try to call Proctorio to say, oh, something is wrong. All right. Any questions? Questions? Everybody doing my assignment. Like I say, everybody know how to get into visual. Like I say, they just some small assignments. Let's look at that because I got some time. Let's look at that this program. Let's look at this program and see what it actually is doing. All right. So if we look at, I don't know which one I told you to do, but I think it's these 2. But if we look at this program, all right, program 1. This first statement here in green, that's a comment. a slash and a slash followed by another slash, not backslash, that's some forward slashes. Slash, slash, anywhere on the line from that point on is a comment, okay? I could have put a comment at the end of this line, slash, slash, what that line is doing, slash, slash, what that line is doing, all right? You can put comments anywhere in your program. But if I put slash, slash at the beginning of this statement here, then that means I'm commenting out that statement, then I'll get an error in my program. Now, so the first line is a comment. The second line, that's a library that I'm loading. IO stream, input, output. That allows me to either print out something or to input something into the computer, whether from the keyboard or from the keyboard. All right. So pound include. Anytime you're going to load a library, you're going to use the pound include. In the next class, in my class, when we get to when you're going to write code, I have students creating their own little library or their own little header file, and you would use the pound include to include it. Using namespace STD. This loads standard libraries so that you don't have to use this STD dot colon in front of certain commands, like the input command, the output command. All right. So this is used and it's not needed if you're going to use this in front of this. But we normally put using namespace STD semicolon, and we're done. All we need to use is the command by itself. So this is needed. Pound include whatever library I'm going to be using, then using namespace STD, the standard library loaded. Now, here is our driving force of our program. This is the main function. All C++ programs must have a main function. If you try to change this name here to MAINN, you get an error. If you try to change to capital MAIN, you'll get an error. If you change to anything other than main, you will get an error. The compiler, a C++ compiler, is looking for this function, the main function in all programs, all right? That's the program, that's the function is looking for first, all right? And being that we just starting, we just gonna have that one program, one function. But as you get into the other classes, we're gonna have other functions that you're gonna create that you can add to your program. But a function consists of a function header and the body that's enclosed in open and closed brackets. And that's the program. So looking at this function header, int, and we said what? Main is the name of the function, open, close parentheses. This int signifies that we're going to be returning something. Return an integer. This integer is 0, and it returns that 0. If I had something like return A, it will return the number 65, because we say return an integer, even though it's the letter A in single quote. But don't worry about that. Int, say we're returning an integer, so that after every statement is executed properly, that return 0 says, okay, it's done and it's completed successfully. Main, like we said, that's given, has to be that name. And then open and close parentheses. Here is where you would put arguments. Being that we have one function, there's no arguments we're passing. So it would just be no argument in here. But when you get to the next course and toward the end of the course, we'll look at passing, how we can pass arguments by value, by reference, etc. All right. Now, the body of the function, open curly brace, close curly brace, embodies surrounds the function. And then you put whatever valid C++ statements you want inside of here. And the only thing we be putting in is C out. C out is a command that really stands for console out. Write the output to your console, which is your screen, your computer screen, computer console. You got these two less than, these are streams. So I'm streaming, I'm sending my information to my console. Console out. All right, class is over. Streaming this, console out, and I'm telling it in double quotes to print out programming is great fun, exclamation point, and close it or the semicolon. And that's the program. Okay, so that's a small C++ program. This program basically is the same exact program, but what it's showing you is how I can separate or break up my cout command, whereas I did cout, I'm streaming, programming is space, right? Y'all catch that, make sure you catch that. Programming is space, and then close the double quotes, then stream again, double quote, great fun, exclamation point, then semicolon, close the double quote, semicolon. So both of them will produce the exact same output, but what? This one I'm streaming once, this one I'm streaming twice. All right, any questions? Any questions? Make sure you do my quizzes, make sure you do the test, all right? And like I say, make sure you work on your program so you can turn them in. Hopefully you got your Visual Studio downloaded. If you don't, you could have went to where at? You could have went here to download. I think when you go to sign the role and Studio Utilities, look here, download Visual Studio, and this is the 2017 version. All right, you can download it here. All right. So, any questions? If there's no questions, I'll see you on next class period. Questions? All right. So I'll see y'all. All right. Y'all have a good one. All right. Do my work. All right.
Thank you.
All right.
you,
You're
Brian.
welcome.
Yes, sir.
All right. Have a good one. And I know I don't be in them chats. Everybody sign the roll, right?
Yes, sir.
All right. So have a good one. I'm about to log out.